we're going to actually undo a rational expression addition subtraction. Okay, and this is called breaking into partial fractions. And basically what we've done to get here is we got a common denominator. So we had these two denominators and we have a common denominator, and we ended up combining the terms in the numerator to get 5 in this case. So how do we go about getting these two parts? So there's some fraction, x over y. There's some fraction, I'll just write it as a over b plus c over d. And we know that these fractions had denominators with factors of a plus b, or b plus 3 and b minus 2. So how do we get from here to here? Or, well, we went from here to here. Now we want to go backwards. We want to know what's in the numerator here and here. So how do we go about solving that? Okay, well, we set it up in this way. So we're going to say that, well, we know we start with some fraction with denominator b minus 2 and another fraction that had a denominator b plus 3. We don't know what the numerator is, okay, but we know that we had to have some number in there. And when we got a common denominator, we would have had to multiply the top and bottom by b plus 3. So we ended up with x times b plus 3. And we'd have to multiply top and bottom here by the other factor, b minus 2. So we would end up with the factor with y times b minus 2. And the fact that our numerator here ended up with no b's, we can say that, well, we can group these coefficients. We could say that the b's go together and the 1's go together, and we could just group them together like this. Okay, so we know that these are like terms. These in the red are like terms here, or the scarlet, and these in the kind of green here are like terms as well. Okay, this is when I expand out those brackets. And when I group the like terms, I end up with this. And this is a strategy that we call equating coefficients. We're just going to solve for x and y, and we need two relationships or two equations to solve for two variables. And we're going to come up with these relationships this way by equating the coefficients. We're going to say that this coefficient must be equal to 0 because there's no b's in the original answer. Okay, so we're going to say that the coefficient of b, x plus y equals 0, or in other words, x equals negative y. Okay, this does not mean that b equals 0. This just means the coefficient on b equals 0. Here, we know that these are the 1's terms, so we know that 3x minus 2y must equal the number left over. Just going to scroll up for a second here. It's got to equal that 5 there, so that's where we get this 3x minus y equals 5. And so we have two relationships. One relationship here, another relationship here. We know this can be solved as a system of equations. Okay, so if I'm just going to do substitution. I'm just going to say that replace the 3x with y, so I'm going to go 3 times negative y minus 2y equals 5. So I get negative 5y equals 5. So I know that y is equal to negative 1. If y is equal to negative 1, I go back up to here and I can see that x must be equal to positive 1. So my original fractions then, my original fraction up here would have been 1 over b minus 2 plus negative 1 over b plus 3. And if I actually try doing this, so this is my answer, this is my partial fractions. So if I actually try doing this problem here, I'm going to end up with b plus 3 plus negative b minus 2 all over the common denominator. And sure enough, the b's cancel out, and I end up with positive 5 over b minus 2, b plus 3. Okay, so there it is. There is the right answer starting with these partial fractions. So I've got the right x and y, and the way I set it up is I just generalized some number x and y. I did my addition method for these rational numbers, rational expressions. I grouped my coefficients, so my b's grouped together, my 1's grouped together, and I set up two equations to solve this system. Okay, so that's pretty complicated, but let's see if we can do that.